the Moyne Peninsula, a wild, remote landscape on Scotland's rugged north coast. Not much happens up here, but all that may be about to change. Because this might be the site of Britain's first spaceport.
When I first heard there was going to be a spaceport here, it was a feeling of sort of amazement, really, just disbelief.
The plan is to launch rockets from this moorland within the next 3 years. Could this be Britain's answer to Cape Canaveral? Welcome to the sky at night. It's the big space stories that grab the headlines. NASA landing rovers on Mars. ESA sending spacecraft to roam the solar system. And the Russian Soyuz sending astronauts to the ISS. So it would be easy to miss a revolution quietly happening in Britain's space industry. Driving this revolution are a new breed of spacecraft called microsatellites. Over 12,000 of them are due to be launched over the next decade, worldwide. And Britain is hoping to get a slice of that action. Tonight, we investigate Britain's attempt to become a major player in a new space race.
We started a moon rocket company over a beer.
We'll find out how microsatellites could benefit us all and visit their proposed launch site.
This will be the first orbital launch from UK soil, and that's going to be really exciting.
And guest presenter Tim Peake celebrates Britain's past glories in space and finds out where it all went wrong. But first, the revolution in satellite technology that's driving Britain's surge into the space race. The story of satellites begins in 1957 with the very first spacecraft, Sputnik. Since then, thousands have been launched, and most have been expensive and big. But now, what was once a small niche in the market, microsatellites, is going mainstream. Surrey Satellites are leaders in the design and manufacture of microsatellites. And I'm joined here by Sir Martin Sweeting, who knows a thing or two about these things. So Martin, when you made the first microsatellite, were you expecting to be still making them today?
No. I mean, we started back in 1979 with this idea to try and take some of the modern components and build a microsatellite. It seemed a crazy idea. I mean, I didn't know anything about spacecraft then. It was the only way I could get into space. I couldn't be an astronaut, so this seemed to be the next best thing. So this was, doing something that I was passionate about, more or less as a hobby, and then it turned into business.
So what do you think is driving this microsatellite revolution?
Well, the thing that really drove it is this enormous investment in microelectronics for consumer electronics. We see it every day in our smartphones, our Xboxes and laptop computers and tablets. The technology that has gone into those things has had a tremendous amount of investment behind it, much more than the space industry itself could afford. Their capabilities have grown to the point where now actually they are really, really useful and they compete with some of the activities of big satellites.
Now, we've been using the term microsatellite, but compared with a standard satellite, what sort of size are we talking?
Well, a microsatellite comes in sort of different sort of sizes even within that, but generally speaking, they are the size of, a large washing machine.
Okay, yes. I can picture that.
Yes.
So what sort of things do they do?
So actually in the 90s, what they did was to provide electronic store and forward, like email services to remote regions before the internet infrastructure existed. But of course, once the internet infrastructure grew, then our focus shifted away from electronic communications towards Earth observation.
In terms of Earth observation, we're getting science, but how about the industrial progress?
Again, rather like the smartphone, who thought of all the applications we have on our smartphone now? Who actually even thought we needed them? But now we've got them, we find they're indispensable. Much the same thing's happening with the microsatellites. All of a sudden, we see companies coming up with this idea and that idea and the other idea. I think when I looked at it last year, there was something like 400 new startup companies looking at all different aspects of these microsatellites and their applications.
That's pretty impressive.
Yeah.
So there's lots of exciting things happening, but where do you see the future of microsatellites going?
Now what we want to do is to assemble the satellites in orbit, so we'll have microsatellites which we launch together, and then in orbit we glue them together like Lego.
Yes.
And then like Lego you can take them apart and put them into different shapes so you can make different attributes.
That sounds like an exciting future, but I have to ask, when's it going to happen?
Well, I mean, hopefully we're going to be doing the first demonstrations of the Lego satellite, if you like, in the next 1 to 2 years. So that's not far off.
Well, thank you so much. It's an exciting time in space.
Thank you.
The rise of microsatellites has given Britain an opportunity to become a bigger player in space. We're a world leader in this rapidly growing field. Currently, some 40% of the world's microsatellites are built here in the UK.
3, 2, 1, 0.
But each and every launch happens abroad, in the nose cone of a rocket built elsewhere. It is predicted that the demand for rocket launches in the UK over the next decade could be of around £3.8 billion. But for this to become a reality, we need a rocket, a British rocket. And there's a group of engineers that are rising to this challenge. Hi, Chris. Lovely to meet you. So you work for a new company called Orbex. Where did this idea come from to actually start a launch vehicle here in the UK?
Well, we started a moon rocket company over a beer, and it really started like that, but it became serious quite quickly. Orbex is building a small space launch vehicle to take small satellites into low Earth orbit. We're building them here in the United Kingdom and in Europe, and we're launching them from Scotland. There's been a big shift in satellites the last decade or so, away from quite big monolithic satellites weighing perhaps a ton or more, to quite small satellites. That's the market we're trying to address.
So your company is effectively doing rocket science, but are you sort of going back to the drawing boards and starting from scratch, or are you utilising things that are already out there?
We're building from scratch, so it's a clean sheet of paper for this launcher. We've got people on board who've worked on Ariane 5. We've got people who've worked on deep space probes to Mars and Saturn and Jupiter. Low Earth orbit satellites and so on. There's also a bunch of people who've got a really rare set of skills, which is actually building rockets with their own hands and failing at it. And failing at building rockets is a really undervalued skill.
But learning from those mistakes, I guess.
Yeah, exactly. You know what works.
So how does it compare to some of the bigger rockets like Ariane?
It's very much smaller. This class of vehicle is called a micro-launcher for a good reason. They're tiny. Our vehicle is 17 metres tall and about 1.3 metres in diameter. It looks like a rocket, it behaves like a rocket, it goes at the same speed as a rocket, it has to be guided with the same precision as any other rocket you've ever seen. The difference in ours is it uses what people might know from cooking and heating, propane, as the core fuel, which is an innovation that makes the rocket very much lighter than any other vehicle in this class. Propane helps us save about 30% of the mass of that small vehicle. And in addition, because we're using propane, we can actually use a variant called biopropane, which is chemically equivalent, but allows us to reduce the carbon output of the vehicle by about 90% compared to standard rocket fuels.
In the future, you'll have a launch capability, but how much work has gone into it? How far along the line are you?
Well, we have an existing factory in Copenhagen that's already building the engines and tanks and avionics there. We're planning a new factory in Scotland. In fact, I'm heading there tomorrow to look at the plans for a new 3,000 square metre factory there that'll be the mission control centre as well. We've kept very quiet about what we're doing in the past 3 or 4 years, deliberately, because we felt it was more important to do real things than talk about things. We'll be launching around 2021, late 2021. The problem with this sector is people always make these launch predictions. They're always wrong, and I'm going to be the next one that'll be wrong for sure. So there'll be a window around that time point where I'll be right. But the longer-term goal, I think, is quite exciting. It will see Britain go back into the space for the first time in half a century.
Well, it feels like about time too, so I'm looking forward to seeing the first launch.
Yeah.
Thank you so much.
Thank you too.
I wish Orbix every success. It's an incredibly exciting endeavour. But it's also good to remember that Britain was making rockets 60 years ago. Taking a look at the first and only time a British-built rocket launched a satellite and where it all went wrong is Tim Peake.
When the space race began in the 50s, Britain was very much part of it, building both the satellites and the rockets that launched them. And that continued right through to the early 70s. And this beast, hanging above me in the Science Museum Space Gallery, is Black Arrow. A 40-foot, three-stage rocket, it was fueled by kerosene and high-test peroxide. Designed to put satellites into orbit, it was developed in the 60s and was successfully launched from Woomera in the outback of South Australia. Its final flight put Prospero, a 66-kilogram British-built satellite, into orbit. And that satellite is still up there and not expected to fall back to Earth for another 50 years or so. Black Arrow was an undoubted success, but for me, the rocket that personifies Britain's successful contribution to the space race is Skylark.
Among our space activities at Bristol, we prepare Skylark sounding rockets with which to probe the Earth's upper atmosphere.
Britain launched a total of 441 Skylark missions over 50 years, making it one of the longest and most successful rocket programs in the world. Initially used for military research, helping to develop the Blue Streak ballistic missile, the broader scientific value of Skylark quickly became apparent. And researchers adapted it to learn more about the Earth, the Sun, and deep space. And now we're joined by Doug Millard, who's responsible for this exhibition at the Science Museum's Space Gallery, celebrating this unsung hero. Doug, hello.
Hi there.
So Skylark, what was its contribution to science?
Well, Skylark was there right at the beginning, back in 1957, the same year as Sputnik, and it really laid the foundations, particularly for the UK's space science programme. Although Skylark didn't get to orbit the Earth, it did get very high indeed, about 500 kilometres during what was quite a short flight time. It was about 10 minutes, but there were those few minutes in the middle of that time when it was at its maximum height, when it could do the science. It would be weightless at that time, and that enables you to have a steady platform to look down on Earth or look up into space to do some astronomy, or even to sound the upper atmosphere.
It will carry experiments which will measure the ionization of the Earth's upper atmosphere and also the radiation of the sun on X-ray and ultraviolet wavelengths.
And Skylark was the predecessor to Black Arrow. How much influence did it have on the Black Arrow program?
Well, at the time, there were several rocket programs. Skylark just kept being fired. It was so successful and relatively simple. Black Arrow was a little more complicated, more sophisticated, but it was this exchange of information between the guys who were working on these rockets which really enabled Black Arrow to also go into space and into orbit.
Black Arrow launched 4 times, which is a great success. So why did British rocketry die?
Well, the problem with the Black Arrow program was that there were not enough of these development satellites, which meant that you could not justify the expenditure of the Black Arrow program. So Black Arrow was cancelled, and the next satellite in this program was launched by an American Scout rocket.
So although Black Arrow was cancelled, do we still see an impact on today's space industry?
So really, the expertise which we now see around us in the UK with the satellite industry, with the space science programs, all of that can be traced back to the 1960s. That's when all the programs laid down the foundations of what we know and are able to do today.
Doug, thanks very much for talking to me.
Great pleasure, thank you.
To date, Prospero is the only all-British satellite to be put into space by a British rocket, which means we are the only country who developed this amazing capability, only to abandon it. Black Arrow and Skylark show what British space engineering can accomplish. And it is amazing to me that we let this expertise wither away. But now there's a chance that we could be back in the game, and I can't wait.
Neither Black Arrow nor Skylark were ever launched from these shores. but the new generation of rockets and satellites may very well be. Down in Cornwall, Virgin Galactic are proposing a horizontal launcher. The rocket will be carried by a 747 into the upper atmosphere, then released. Whilst in the far north of Scotland, there are plans for a classic vertical launch.
The launch site will be in this sort of direction, towards Ben Hujik. Not as far as that, but mid-distance towards Ben Hujik. I'm Dorothy Pritchard, and I was born and brought up here. This landscape's been part of my life, all my life. I've worked here, gathered sheep off this landscape. That's something you want to protect and love, really, and look after. The idea of a spaceport was first mooted when Highlands and Islands Enterprise approached us 2.5 years ago and suggested that this area was ideal for a small satellite launch site.
As incredible as a Scottish spaceport sounds, this is a very real proposition, as I discovered back down in London.
Hi Nick, lovely to meet you. Seeing footage of the potential launch site, and it sort of looks really a little bleak and grim. But take me through. Show me what the spaceport's going to be.
I have to admit, the times I've been there, it has been anything but.
Why build it there?
There are a number of reasons. From our perspective, it's a really good location for access into the orbits that we're most interested in. So specifically, that's the polar orbit, which is where a lot of the telecoms and telecommunications, small satellites will be able to operate on. They go over the polar regions. But also sun-synchronous orbit, which is really good if you're trying to observe the world or observe the Earth. The other reasons, of course, are just trying to find a location where there is enough space to build the port as well. And from the UK Space Agency perspective, they're very interested in trying to find those locations where they'll be able to have a really good economic impact and to be able to help the local area.
For the locals, the economic and social benefits of a spaceport on their doorstep are something to be welcomed.
It's a very, very exciting prospect. It could bring a lot of jobs and regenerate this area because it's really in decline. We're an ageing population here, no work for young people. We're hoping that there'll be apprenticeships for young people there. We don't have the expertise, we know that in space, in satellite production or satellite launching, but hopefully you can train young people and give them opportunities to see that as future employment. There are potential downsides. The environmental issues, safety issues, things like that obviously cause concern, but there are some good companies involved and they are aware of how beautiful these surroundings are and the need to look after them. There's still people who croft here, have their animals on this ground and will continue to do that. That won't stop. And we're not selling our land, we're leasing it. So we'll still have control over it. And that's the good thing. And I think the crofters, that's the way they would want it.
For the team planning the launch site, the remoteness of the Moyne Peninsula is part of the attraction.
The rocket does contain a lot of fuel, and you will be lighting that fuel. So a part of it is, of course, to make sure the exclusion zone is easily monitored and easily controlled. And the UK Space Agency have said from the outset, one of their primary objectives is to make sure that this will be a safe launch. And of course, we're absolutely on board with that, and we'll do all we can to help that.
So when people think of space, they think of NASA, they think of the European Space Agency. Will people in the future be thinking of the UK as a hub of sort of space launches?
You've been to some of the large spaceports, and the ones who launch the big geosynchronous or big geostationary satellites or the large sort of NASA missions, they take a lot of infrastructure and they take a lot of support. That's not what we're going to have. You'll expect to see a building there, which is where the integration will take place of the satellites with the rocket itself. There'll be a strip of tarmac that will go out to a launch pad, but it won't be too long, a few hundred meters. So then you'll bring the rocket out, bring it across this strip, and then put it onto the pad. And there'll probably be a road taking you to that. But from an infrastructure perspective, that's probably about all you'll see.
So this all sounds fantastic and really exciting. But when will that first launch happen?
we were hoping to have the first launch by the end of 2020. Ideally, as close to that date as possible, maybe into 2021, but as soon as possible. This will be the first orbital launch from UK soil, and that's going to be really exciting.
Well, we're just looking forward to seeing that first launch, so please do invite us. We'd love to see it.
Absolutely.
Thank you so much. It's fascinating and very exciting. Building a spaceport on British soil means that a remarkable future is in sight. A future where Britain builds the satellite, but also builds the rocket to launch the satellite and launches the satellites from these shores. But the question is, what will the satellites do when they get into orbit?
We'll be finding out about that soon. But first, some of the thousands of satellites that we've put into orbit are actually visible in the night sky. And Pete is down in Sussex to show us how to observe them, and one in particular that you'll have to be quick to catch.
Over 20 years ago, the Iridium Communication Company launched its first satellite into low Earth orbit. And by 2003, the fleet had grown to 72. That's known as the Iridium constellation. Now, I'm here at Ipping Common, one of the UK's excellent dark discovery sites, to see whether I can catch a glimpse of one of these man-made objects. The Iridium satellite has 3 large polished antennae that can reflect the sun's light back to Earth, creating a flash. The phenomenon is known as an iridium flare. Now, typically it will only last for a few seconds, but some can become as bright as magnitude -8. That's 30 times brighter than Venus, the brightest planet in the sky. If you want to try and spot this flare, then there are timetables online that predict where satellites and the flares can be seen from your location. They'll also provide the altitude and azimuth. So armed with the knowledge that there is an iridium flare going to happen tonight, a really bright one, that's going to occur at 20:03 at an altitude of 57 degrees and an azimuth of 121 degrees. That puts it right on the eastern wing of Cygnus the Swan. So I'm going to have a go at photographing it. So this is with the naked eye, but it's also a popular photographic target, and the best kit to use for that is a regular DSLR fitted with a wide field lens. Now, if you're up for the challenge, you can image or video it through a telescope. It's quite hard to keep track of, but the results really make the effort worthwhile.
Whilst engineering teams are busy producing new satellites, new rockets and launch sites, one question remains: what will they be used for? Down in Guildford, one company, Earth Eye, are harnessing microsatellites to survey the planet to a level of detail that was once only available to the military.
So we've been doing a tour of the UK space industry. We've seen launchers, we've seen satellites, but you don't do that here at Earth Eye. So what do you do?
Well, we use still imagery data, and what that means is that we essentially take pictures from space. This is a good example. This is actually the royal wedding, Harry and Meghan, just this summer just gone. This is a great example of a very high-resolution still image. If we were to zoom in onto this, every single pixel that we can see on the screen here would represent about 80 centimetres on the ground.
So that is quite a lot of detail that you can see from space. Should the public be worried?
Not at all, no. It's very difficult, indeed impossible, to track individuals with these satellites. Not only are they not overhead for long enough, but they just simply don't have the detail to be able to do that sort of work.
This image is very different. This looks much more rural. What sort of information can you get from this?
This is part of a project that we ran this summer whereby in the UK we've had such a dry summer, of course, and we've been able to see some really interesting features with the land. And by imaging the land and overlaying water pipe networks, we've actually been able to identify underground leaks.
The current technology generally involves stills, but you've developed new technology to change that.
That's right. So the really exciting thing here is this satellite that we see here, which was launched in January 2018. This is a prototype Pathfinder mission for colour video in high definition from space. This is a UK first, so taking this sort of level of detail with such large areas on a regular basis is entirely new for our industry. The next plan, of course, is to put multiple of these spacecraft up. So we're expecting that within the next couple of years we'll have our first batch of 5, and 12 to 14 months after that a further 5.
So what are we seeing in this video?
So this is an image of Buenos Aires, actually a video. We can see the traffic moving down here. We can see a bit of wispy cloud. That's right, just moving out of the way there very conveniently. And if we look at the level of detail we can see here, we can see cars, trucks, trains, even on this container port here, we can see containers being moved around as well.
Slowly across.
That's right.
That's amazing. So this is another example of a video from space. But what are we seeing here? Oh, I can see an aeroplane.
Yes, yeah, that's right. So this is just a very short extract of a clip where we can see an A380 taking off from Dubai Airport. This allows us to build up patterns of life. We can see vehicle movements on the apron and on the surrounding roads, with traffic patterns nearby as well.
So we're seeing the flight, but now we're getting extra details about it.
That's right. So what we're doing here is integrating open source information, so we can see what the flight is, we can see the airline, the destination, what sort of aircraft it is, and of course we can timestamp that.
You know, the next generation.
Thanks very much indeed, Maggie.
Thank you.
The future for our space industry looks bright. But for me, there's one big question. Will we really see rockets launched from these shores?
Well, I'm relatively optimistic, because there's a big difference between what happened in the past and what's happening now. Today's space industry is driven by companies who believe that they can make a profit out of rocket launches, which means the whole programme is much less vulnerable to the fluctuations in government funding. But whatever happens, we'll be keeping an eye on this renaissance in the British space industry. Good night.
The Sky at Night Book of the Moon, a guide to our closest neighbour, is now available. Brian Cox boldly goes exploring the most wonderful thing in our universe, us, Human Universe, on BBC iPlayer now, and next tonight on BBC4, Oscar hopes dashed in a sensational double bill of Feud.